What's up, guys? Today, we're still in machine learning, and today we're going to do lab 6, hyperparameter tuning. And so, yeah, task 1, we will have to split the dataset and training set. This has been done in lab 5. So we will have to jump to task 2, right? Which is manual tuning. And task 3, hyperparameter tuning using random search and grid search, right? And task 4, we will have to do same lab classification and performance evaluation. So let's get it on. Two important files that we moved from lab 5 directory folder to lab 6 directory folder are these files. So this is like from task 1, right? This will be our model dataset, right? For the entire lab 6. I'm not using asthma dataset. And also, this is the combined 30 malware and 30 benign that we will use for testing, right? So pretty much we're done with this part of lab task 1. It says remove the sample dataset, upload the test to Kali, and we just get ready to download to Metasploit, right? So pretty much if we come over here and yeah, let's the directory, those are already uploaded to Kali. And if we go to Metasploit 3, we can view them here online. It's been hosted in Kali web server, right? And so yeah, we can download it from here. So for testing, we can just download one, and it is saving. Great. Okay, guys, we're task 2.4. Create a script, calculate prints and cross validation using tenfold score using F1 or Office scenario, and calculate mean and standard deviation in each scenario, right? It says tenfold here, but in here, this is task 2, we'll have to use 15-fold. So, well, we'll use 15, right? Just to satisfy everything. So, pretty much, guys, we will just have to look at this. So, 15 is there. We load the dataset. This is our all benign and malware, and we used to 30 malware and 30 benign, right? So that is our CSV input right there, right? And so it wants us to select KBAS Chai2, right? And it's there. And we're setting up the values for X train and Y train, and great cross validation and define search, right? This is it looks like to me is grid search because we're using this kind of parameters. And so let's run this program, guys, and it's gonna iterate 20 times as it needed, right? Because over here 4 times 5 is 20 total iteration cross validation. So yeah, we have 20 over there, and I also printed what has been selected, and yeah, 15. Oh no, yeah, this is 15 itself, right? So it looked like scenario 7 is the highest over here. Kernel RBF C equal to 10, right? There's 9678. There's nothing else higher than this one. Yeah, number 7, kernel RBF and C10 is the highest ratings. That's a little lower, 96785. Oh yeah, this one number 3 too. Kernel RBF, but C is equal to 100. It's pretty much exactly the same. Even the standard deviation in the min score. Wow. Okay, task 2 is complete. Let's move to task 3. Pretty much this is the guideline here. Create a Python script and repeat B2H, right? Create SPC model, right? And so yeah, this is my Python program that will do task 3. That's a.py, loading the dataset, the same dataset that we use, and then I split it, right? And then we still have to select KBEST, K15, right? For this task, and it says B2H. We will have to do the B2H, and then yeah, what is B2H is that create a frame, select KBEST, train X and Y. It's there, and then set value, create cross validation object, right? There we go. It's right there, and it says that we will have to use a SVC model, right? Right there, SVC model object, and we will have to define the search space over here. So there might be some library updates. The manual gave us different, like this one here, what did not work for me well. So I will have to find another parameter that will work for me. And this is what it worked for me for C and solve, right? And so we will have to define search using randomized search according to the manual right here. Okay, I'm looking at a different one. Actually, we're still here, lab 6C, right? Which is lab task 3A. I apologize. We're still here, and this is the equivalent of my script, lab 6B, right? So this would be lab task 3B in this part. So I'm still here, guys. And so we will have to execute search results and print the best scores and best parameters. Sorry, I got confused a little bit there. And so these are the, here we define the search and print the best scores and best parameters. Very nice. And guys, for this task A, we will have this result when I run the program, right? So I don't need to show you over the video because it took a while to generate results. So let's just capture it this way. It says that the best score that it found is C1 kernel algorithm and Sol 1E05, right? So let's move on to the next task, which is lab task 3B, right? This one is using the randomized search CB result. Therefore, this is doing the grid search, right? So pretty much the same thing, except only that this will use the grid search. This is according to the manual right here, which I'm reading earlier, where I got confused. The task C, lab C. We're using the grid search this time. And so this is what I meant, grid search. Pretty much all the same, except for this grid search object, right? So by running this program, okay, when we run this program, we got this result. Grid search 9778099, etc. And the max depth 20 and estimator is 10. That's kind of parameter we choose. So compared to our result before with the other kind of search, right? Which is this is the randomized search and it's a grid search. Grid search is much better. Best scores 977 compared to randomized search, right? And yeah, I noticed, guys, when I'm using the randomized search, it's actually faster result, but grid search took longer because, as you can see here, it selected more features for some reason. So that's the nature of the grid search method. So actually, grid search is a reliable method for finding the best hyperparameters, but can be resourceful, expensive. Randomized search CB is more efficient method, which may not guarantee finding the absolute best hyperparameters, but can provide good results with less computational cost. The choice between the two depends on the computational resources and the specific problems we're trying to solve. For my kind of dataset input, I would like to use grid search CB. This is because I think this is just simply fit on the malware and benign search. As you can see, guys, the downloads are here already, right? I started with all benign just to have idea what we're doing, right? So I'll continue this. Save. And if you will take a look at it, it's being currently being classified.
So guys, we're now in task 4 of live classification.
Ubuntu. Right here in this program. Here it's running, right? The detector. So there are a couple of files already been classified, and it's gonna give us this one here, L6 detector.log, right? Which is we can currently look at the contents of that file while it's doing the classification. And it pretty much did all that, except this one made mistake here. Made mistake 1. So I was doing all benign first, right? And then I'll do the malware later. As you can see, we've done all, like the file, that readable for the benign. These files here, I think they're also benign because there's fewer benign than that I can see. Yeah, I think they're benign. So let me start this one, guys. So I started from here, all the benign, and I assume these are also benign, right? Kappa read it before I throw it here, so those should be classified as benign. I will count them later. So I'm gonna start the malware now. From here to here, look like that's around 30 malware, so I'm gonna start it to download it. Not run it. It will execute on Windows. Let me finish up this, guys. So we have 33 for benign, and for malware we have 34. 8 times 4, 32 plus 2 is 34, right? So we'll see if it's gonna come up. All the malware here so far is doing good. Let's classify all malware. Very good. There are 3 benign files here, and so it just bit 33, right? So let me see. 34. Yeah, 33. Or supposed to be benign, but he made a mistake. Three lines. That's not bad though. It classified 31 files correctly. So far, guys, it's still classifying. It takes a while. I'm just pausing this to actually put the highlights of this video. So the program is still running, right? Detector. As you can see, the processor is still loading there. That's stop. That means that it's all classified. And another indication is that when we open this one, it should have 33 plus 34, 73, right? Now, one thing I noticed here, guys, see here, it did very good in identifying benign up to here. So from those things, it just made three mistakes, right? Like I said earlier. But from here, 34, this is a batch of all malware that I did. And it's not very good in identifying the malware. So my program failed somehow to identify malware. It did good in benign, like I said. So it's like almost 60% it identified malware. But you see, it's almost benign there. Around 50-50, I think. Wow. So guys, it's done. Classifying the files, reading and classifying. There are two files here that did not read to the malware batch. So we expect a little less. It's not everything was read. So if we look at the thing, the detector.log, yeah, I could say 50-50. It read 50-50 on malware, 50 benign. This is supposed to be pure malware from this line here, the 34, all the way down. But this is what strains going on. I don't know, maybe the CPU is tired or classifying. It did good in benign, like I said. So yeah. Anyway, it's finished loading and it's waiting for more load, but we successfully fit in the whole batches of benign and malwares, and the CPU is not working anymore. So we will terminate the program. Right, so that's the program I ran, the detector. Right. Oh. Yeah, so it's gonna load this to pickle file for the classifier and the feature model. So great. Let's move on to the next task. Okay, guys. So this is for lab task 4. Lab task 4. We will have to create a new Python script for the detector, right? And create a print classification and display the confusion matrix. So to accomplish this, we need two files input, right? We need to input this log detector log, and also the one that we separated in task 1, right? Which is this one, the target. I rename it to target, a lot easier for the program to identify it. This was from task 1 that we combined the 30 malware and 30 for tests, right? And with this detector log file, right, I will have to convert this to CSV, right? This is how it looked like on the classification, live classification, and then I convert it to this. Not this one. This one, I delete the timestamp and also the timestamp. Yeah, I deleted the timestamp column and just leave the MD5 and classification to match with our test input. And so after, we will have to create and print classification report, display the confusion matrix, and plot the ROC curve. Pretty much it showed a proof of concept in this regard. And with this plot, it shows this line, which it gives us this mean line to 1, right? Which is a graph showing that the precision over there is 1. And so it graph really, it's a ROC curve area showing that 85%, right? It's achieved 85% of the classification obtained. So thank you for watching, guys, and I hope you like my video, and thanks for your time. Have a nice day. And so yeah, like I said, it loads the two files input, and then it will compare it and read it, and then it will classify itself, print the classification report, display confusion matrix, and plot the ROC curve. So let's run this, guys. Okay, so we have this. Let's hide down. Now accuracy on the benign, it says 82%, right? 82% for the F1 score. For the malware, it did a little poorly, 68%, right? But it's all right, but we like more, right? So I will have to revisit this lab one day and why that is, but it's a good concept to learn machine learning.